Polygon angles. There's 3 rules which will pretty much cover this subject, and I'm going to teach you a way of remembering them. Polygons, these little shapes made with straight lines, all have 3 things in common. The first thing, a polygon is a shape made out of straight lines, and the lines meet at corners called vertices. This is a vertex, which is also known as a corner. Inside, the angle is called the interior angle, and outside, the angle is called the external angle. And you can see it's sort of defined as this line is continued, and then it's this angle around here. So this adds up to 180 because the angles on a straight line are 180. Internal and external equals 180. Rule number 1. Rule number 2. Total interior angles is equal to the number of sides minus 2 times 180. If a polygon is regular, then each interior angle can be found because they're all the same. A regular pentagon has 5 sides. What's the interior angle at each vertex? Well, it's not going to help us drawing it, to be honest. What's that angle there? The total interior angles is sides minus 2 times 180. Sides minus 2 is 3. 3 times 180, 540. But this is a regular pentagon, therefore we can divide this by 5 and find out the angle of each internal angle. Internal angle at each of the 5 corners, 540 divided by 5, 108. Brilliant. Incredibly useful formula. And finally, there is an external angle at each vertex, corner, and there it is. We continue this line on and draw this angle here. This is the exterior. If we drew this line, extended it, and drew another angle here, that would be an exterior angle. It'll be the same angle. Opposite angles are the same. But anyway, external angles of any polygon add up to 360. So here's a proof. Place a pencil on the edge of a polygon. There's a pencil. Slide the pencil along each edge. It slid along the edge. Rotate the pencil through each external angle. And there's the external angle. I'm rotating it, I'm sliding it, I'm rotating it, slide it, rotate, slide and rotate, slide and rotate. The pencil will rotate through 360 degrees. Let's see that again. Notice the pencil's pointing this way and the head of the pencil's at this end pointing this way. And let's rotate it around each of these external angles. And lo and behold, it's pointing in that direction again, having gone all the way around. The 3 rules of polygons. How do we remember them? Well, they're all about internal and external angles. And how many permutations of the phrase internal and external are there? Well, there's 3. There's internal and external. There's internal on its own, and there's external on its own. And each of these permutations has a rule. Internal and external. Well, internal plus external equals 180. That's an easy one. Internal angles equals sides minus 2 times 180. So think of a triangle, sides minus 2, well that's 1 times 180, yeah, that's 180 inside a triangle, we know that. And external angles add up to 360. This one is commonly forgotten or not taught. Either way, very useful. Here's an example of a square. The external angles are 90. Square, the total is 90 times 4, which equals 360. So when you have an idle moment, just think, what are those 3 rules? Oh yes, permutations of internal and external. Here's a question. A regular octagon has 8 sides. Regular is important. Octagon, 8 sides. What is the internal angle of an octagon? I should have said the octagon. Think. Internal and external, internal or external. Which one is it? Well, it's all about internal angles, so I'll go with this one. Total internal angles, sides minus 2 times 180. Well, that's going to be easy, isn't it? 8 sides, so total angles is 8 minus 2 times 180 equals 1080. I do hope we've got this is a calculator question. Each internal angle, well, there are 8 of them, so 1080 divided by 8 is equal to 135. That's pretty simple. And a check. See, if you could do it this way using this formula, let's see if we can check it using this formula and this formula. External angles, we know they add up to 360, but there are 8 sides and 8 corners, so each exterior angle is 360 divided by 8, which is 45. And we know interior plus exterior equals 180. Does it? Interior and exterior, well, our internal is going to be 135, and our exterior, we've calculated 45 equals 180. I'd be very happy with that. Very confident that's the correct answer. So we had to think, which of the formulas are we going to use? The calculations was relatively simple, and then the check. The check almost is harder than the question, to be honest, so maybe it's something to do when you've got a bit of time left over at the end. Here's another example, and this uses one of my favourite and generally not well-known rules about exterior angles. Each exterior angle of a regular polygon is 15 degrees. Work out the number of sides of the polygon. Right, well, so it's telling us this sort of thing, and which one of these should we use? Well, we're definitely going to use something to do with exterior. That or that. That one tells us what this angle is. At least we can work it out. I'm not sure that's any great use. The total exterior angle is 360. Bingo. Absolutely brilliant. Remember this. The same number of sides as angles. Okay. So think of a square. 4 corners, 4 sides. Think of a triangle. 3 corners, 3 angles, and 3 sides. So if we know that, then angles times exterior equals 360. The angles times each exterior angle is the total number of exterior angles equals 360. So the sides times 15 in this case, because that's what our polygon's exterior angle is 360. Let's divide by 15. So the sides equals 360 divided by 15 equals 24. This is going the other way. Normally they tell us how many sides there are and ask us what the angle is. But this is going the other way, and that's why this question was poorly answered, although I don't think it's that difficult. So we have a little check. So let's say the sides were 24. The total interior angle, 24 minus 2 times 180. Oh, this is not 1. This is not 1 if you haven't got a calculator. 3960. So we divide that by 24 to find each individual interior angle, 165. And we know that interior plus exterior equals 180. Interior plus exterior, 165 plus 15 is 180. That's very happy. This check is a lot harder than the question. The question is, well, each exterior is 15. All the exterior angles equals 360. So we'll divide 360 by 15 and we'll get the number of sides. We'll get the number of corners, and the corners is the same as the number of sides, 24. If you know what you're doing, that is an easy 2 or 3 points. Have a think, crunch some numbers. Checking in this case is harder than the question, so you might leave it to the end. Right, this is the process for me. These are the 3 things you know: interior, exterior, and exterior. One of those is going to solve your problem. Find out which one it is, insert the given values, solve the equation, and then check it. And it's an idea to check it using a different method. And this is really useful. Total exterior equals 360. People tend to forget it. Anyway, here's an opportunity for you to show your genius. It's a pause and practice. Pause it and I'll give you the answer at the end. Alright, we need a bit more space for this. This is a nasty looking thing, isn't it? A regular pentagon and a square. Right, well, we know what this is. That's 90. We don't know what the internal angle of a pentagon is unless you've worked it out and remembered it. So work out the angle x. Okay, right, so x. Show you working. So one of the interesting things, I think, is what we're going to use here. We are going to use the idea that going round from a point, all the angles add up to 360. So this is 90, this is x. We need to know what this angle is. We need the interior angle of a pentagon. Find the interior angle of a pentagon and then use angles round a point equals 360. Total interior angles is sides minus 2 times 180. 3 times 180, 540. How many angles are there? There's 5 identical angles. Each interior angle is equal to 540 over 5, 180. So now we can put 180 here. We know this is 90, might have marked that before. All this lot are going to add up to 360. So 180 plus 90 plus x equals 360. I need x. So I want to get rid of 108 and 90, so I shall subtract them from both sides. And I get x equals 360 minus 108 minus 90, and that's going to give me x equals 162. Brilliant. I'd probably be happy with that, but I might want to check that the 108 is in fact the interior angle. So first of all, let's check the addition. Yes, when I put it back in, it does add to 360. Exteriors equals 360 divided by 5 equals 72. So the exterior angle of a pentagon is 72. And int plus x equals 108 plus 72 is equal 180. So I'm very happy that this 108 is in fact correct. And there's a good few marks there. Lots of tricky things which are hard unless you've seen them before. And now you've seen them before. Have a think, do a calculation, and then have a go at checking it if you've got time. It is tricky, these little interior external calculations, unless you know the 3 rules. And if you know the 3 rules, then it's easy. So just learn the 3 rules. So if you've enjoyed this video, or even if you haven't, why not subscribe and learn more? There's plenty more videos coming. Thank you. Best of luck.